Hi, it's Mrs. Pope, and today we're going to talk about inverse functions and relations. Our goal is to find the inverse of a relation or a function, and also to determine if two functions are inverses. So first, definition. And inverse relations are found by switching the x and y in a relation. So if you have an ordered pair, a set of ordered pairs, just switch the x and y's. That's the inverse. Pretty simple. The domain becomes the range, and the range becomes the domain. That's what happens when you switch the x and y's. Remember, domain is x values, and the range are the y values. So, example 1, let's find the inverse of this triangle. So these are the points on the triangle, and that's the the red triangle that I've graphed here. And we want to find the inverse. So what it says is switch the x's and y's. So instead of 1, -2, I'm going to have -2, 1. Instead of 2, 5, I'm going to have 5, 2. Instead of 4, -1, I'm going to have -1, 4. If I flip these and actually graph them, that's the blue triangle, you'll see that it is each triangle is reflected over the line y equals x. And we know that y equals x is the identity function. So by finding the inverse, you are actually reflecting the image over the y equals x line. So notice the B and B, they just flipped over this line here. The C was top left, flipped down here to be bottom right. The A's, again, they flipped as well. So you basically took everything that was on the right side of this, acted as though this were a mirror, put it on this side, and then the same for whatever was on the top of the line, put it on the bottom. So it just reflects and acts as if y equals x is a mirror. And that's what happens when you find the inverse. So example 2, let's find the inverse of not just ordered pairs, but actually of a function. So f of x equals 2x minus 5. Just remember, whenever you see f of x, you can just replace it with y. It means the exact same thing. It's just called function notation. So I don't want to always just put y, because you will see in your further math classes f of x, and we need to understand that it's the exact same thing. So the inverse here, when we're finding the inverse, all we want to do is switch x and y and solve for, that looks like an x, it should be a y, solve for y. So it normally said y equals 2x minus 5. So the inverse is x equals 2y minus 5. I just switched the letter x and y, and now I'm going to solve for y. So add 5 to both sides. X plus 5 equals 2y. Divide by 2, divide by 2. Y is equal to x plus 5 over 2. I like to separate them. That's just me, because I like to see my slope, because I can see easier here. My slope is 1/2. My y-intercept is 5 over 2 or 2.5. Either way. Sometimes I just think it helps to graph. So let's graph both of them. The first one, y equals 2x minus 5. Well, we start at the y-intercept. This is a review of graphing. Start at -5. 1, 2, 3, 4, 5. Is that 5? 1, 2, 3, 4, 5. Yeah. Go up 2 over 1. Up 2 over 1. Up 2 over 1. Graph that line. This is y equals 2x minus 5. Now let's graph the inverse. Start at 5/2 or 2.5. So up 2.5. There's my first point. Now I need to go up 1 over 2. Up 1 to 3.5 over 2. Up 1 over 2. It's hard to see that. All right, there's this line. And this is y equals x over 2 plus 5 over 2. And if you notice, if I had the line y equals x, the inverse line on there, these have just flipped over the line. So this long part here, it reflected and became this long part. This part here reflected, and I mean I could have made this longer just so you can see it a little better. That flipped and became that part. So you're just flipping them over the line y equals x by finding the inverse. All right, let's verify that two functions are actually inverses. So if I say, are these functions inverses, you need to verify it algebraically and then answer yes or no. So example 3, here's f of x, here's g of x. These functions are inverses if and only if, so it goes both ways. Their composites are the identity function. What? Another way, or you could say if, this is the composite, f of g of x comes out to equal x, and g of f of x comes out to equal x. So that means their composites, this is their composites, are the identity function. Identity function is just y equals x. So let's try it. F of g of x. Remember, let's write out the f function. Leave a big old space for that x, plus 9. Stick g of x inside there. 1/3 x minus 3. And solve. So 3 times 1/3 is just going to be 1. So we're going to be left with 1x minus 9 plus 9. So this is going to cancel out. So I'm left with x. 9 minus 9 would cancel out. I'm just left with x. So this one works because the composite comes out to be the identity function. Let's try the other one. G of f of x. Start with the g function. 1/3, leave a big old space, minus 3. So I wrote my g function. Now let's plug f of x in there. 3x plus 9. Solve it. 1/3 times 3 again is going to be 1x. 1/3 of 9 is going to be 9 divided by 3, which is 3. Plus 3 minus 3, those are going to go away. I'm left with just x. So, yes, these two are actual inverses because when I did f of g of x, I got x. And when I did g of f of x, I got x. You have to get them for both or they are not considered inverse functions. All right, some to try on your own. I'd like you to write these down, pause the video, try them on your own, all of them, and then come back and see if you got the answer. I'll write the answer at the bottom. I won't go through how to do it right here if you have questions in class. But the best way for you to take advantage of this is actually stop the video and do it on your own. Okay? So find the inverse of y equals 4x minus 6. Find the inverse of y equals x minus 4 over 3. And tell me, are f of x and g of x inverses? If f of x is 4x plus 6 and g of x is x minus 6 over 4. Pause, try them out, come back and get the answers. All right, hopefully you're back now. Hopefully you actually stopped the video. So, number 1, you should have come out with y equals x plus 6 over 4. Number 2, you should have come out with y equals 3x plus 4. And number 3, yes, those two did work and they were inverses. Hopefully you got those all right, and thanks for watching. Remember, you are responsible for your own learning.